The question reads graph. The function given is f of x is equal to 6x minus x cubed minus x to the fifth. This is not written in standard form. I would recommend changing this to the opposite of x to the fifth, minus x cubed plus 6x. And we will follow the procedure given in the lecture notes. First thing we need to find is in behavior. Using in behavior, I recognize that my degree is 5 and my leading coefficient is -1. This tells me that I will rise left and fall right. I need to find x-intercepts. To do that, I have to set my function equal to 0. So the opposite of x to the fifth minus x cubed plus 6x is equal to 0. I am going to factor out a negative x, leaving me with x to the fourth plus x squared minus 6 is equal to 0. There are factors of 6 that if I subtract leave me with 1. So this is actually a factorable expression. So negative x times x squared plus 3 times x squared minus 2 is equal to 0. So we can say negative x is equal to 0. X squared plus 3 is equal to 0. X squared minus 2 is equal to 0. I can divide by -1, so x is 0. I can subtract 3 from both sides. X squared is equal to a -3. This is imaginary because I cannot take the square root of a negative number without going imaginary. So I'm not going to finish this part of the question. I will add 2 to both sides. X squared is equal to 2. Take the square root of both sides. X is equal to plus or minus the square root of 2, or the approximation is plus or minus 1.41. So my x-intercepts will be a -1.41, 0, 0, 0, 1.41, 0. We would also like to find the x-intercept. To find the x-intercept, we will plug in 0 for the x. So f of 0 is equal to the opposite of 0 to the fifth minus 0 cubed plus 6 times 0, which is equal to 0. So the y-intercept is 0, 0. I would like to know the maximum number of turning points To find the maximum number of turning points, I take my highest power, which is 5, minus 1, will give me 4. So I have a max of 4 turning points. I don't have to turn 4 times, but I cannot turn more than 4 times. Let's see exactly what all I have on my graph to see if I need any more information. Okay. So I know as I'm rising to the left, I am falling to the right. I know I have x-intercepts at negative 1.4, 1, at 0, 0, and at 1.41. I also know I have a y-intercept at 0, and I can't have any more than 4 turning points. Okay. We're not looking for an exact picture. We call that curve sketching. But I want a shape that could possibly happen. Okay. I would like to know what's going on between negative 1.41 and 0, because my graph has to turn in there somewhere. So I want to find additional points. And I'll use negative 1. It's a whole number. It'll be easy to find for the most part. So I'll plug that into the function. So I have the opposite of negative 1 to the 5th minus negative 1 cubed plus 6 times a negative 1. As I work that out, I have negative 4. So the point is negative 1, negative 4. I also would like to know what's happening between 0 and a positive 1.41. I'm going to pick 1, since it's the nice whole number there, and plug that in. So the opposite of 1 to the 5th minus 1 cubed plus 6 times 1 gives me a positive 4, which is 1, 4 is the point. And I'll plot those in my nice pretty picture. 1, 2, 3, 4. So right about there. 1, 2, 3, 4. Right about there. Gives my graph an idea. We're turning here, going up through 0, 0. We're turning there, going down through positive 1.4. And we'll go up through a negative 1.4, and my graph looks something like this. It's the shape.